Hello again, everyone. This is going to be another video of just MultiSim basics, and we're going to go into logic gates a little bit deeper here, as that applies to today's lab. Okay, so first we're going to go back to place components, where we always begin. Component. So another thing that I didn't show you in the last video is digital probes. So we will be using these in today's lab. So digital probes are under indicators, and under probe, and then you have various colors, blue, green, orange, red, yellow, etc. So the way that these work are they have a certain threshold voltage, and once they reach that voltage they turn on. So once we place it, we'll see, you see this 2.5 volts here. So that means once this reads 2.5 volts, it'll light up red. So we use these with logic gates to simulate our output of a gate, that when it's 0, obviously this will be off, and when it's above our threshold, which for logic gates and TTL is around 5 volts, it'll light up. So if we want to adjust this threshold value, all we have to do is double click, and we see here we can adjust it. So we want to make it about 4.5 for our purposes today. Okay, so we've got our probe here. So now we need our logic gate. So we're going to right click, place component, go back to TTL. So these are our gates. So we'll just go with a basic NAND gate here, the first one that they throw up. So now this is just a single logic gate, and it's offered as part of a chip. Obviously the 7400 is a chip. So you'll see once we place this one, it's going to ask us if we want a B, a C, a D, because the actual chip itself has 4 gates. So new A, you just click A. So we just want the one, so we're going to hit cancel and then exit out of here. So now we have one logic gate which simulates 3 pins on your IC of the 7400. Okay, so we'll connect our output directly to our probe, and then now we need a power source, a resistor, and some grounds and some switches to simulate a 0 input and a 1 input. So we'll start with our power source. So we'll go place component, sources, power source. Now we're going to use DC power. We could also just use VCC, but sometimes that gets a little tricky if you use more than one source, because they have digital pins, they call them, and they connect automatically and it can screw things up. So we'll just stick with DC power. So we have a DC power source. Now I'm going to go ahead and rotate it. You just press Control R and that rotates it. So now you should be familiar. Well, we're going to need 2 of these first of all, so I'll place another one. Control R. Okay, then we'll exit. So now you should be familiar with the symbol for a DC power source. So the larger bar, obviously on the right, that's your plus side, and then this is your minus. So this is going to just get wired to ground. But before we do that, we want to change these to 5 volts, which is our TTL level. So we'll double click, 5 volts. Okay, again, double click, 5 volts, done. Okay. So now the way that these are going to work is they're going to be wired to a resistor on this side so that we draw some current, and then they're going to be wired to a ground over here. Okay, so, and then we'll have a switch interrupting them. So we're going to have these guys pretty much in line. Okay, now we need 2 switches, so we'll place component, basic, switch, single pull, single throw. So we'll need 2 of these as well. So we're going to have one here, and then we can just hit OK again and place our second one down here, just to keep things kind of a little more organized. We'll move this down a little bit, get it out of the way. Okay, so we'll wire this to here, and we wire this to our other input. Okay, so now we need 4 grounds total. We need one here, and one on either side of our power sources. So place component, sources, ground. So let's say we place our first ground and then we accidentally exit out of here. Instead of having to go back through place component and everything, we can highlight this, Control C, just like you're in Microsoft Word, Control V, and you get another ground. And then we need our third ground, Control V, and then Control V for our fourth ground. That simple, instead of having to go through the menu every time. So now we'll wire these to ground, this to ground, and this is our minus side of our DC power source to ground, and same over here. So now we need 2 resistors, 330 ohm resistors, your standard when you're working with TTL or LEDs or anything like that. Move this over. Once you have components placed, by the way, you can move them and it'll automatically adjust the wires if you just want to make things neater or you need more room somewhere. So now we're going to place our resistors, sources. So we'll go to basic, resistor. I said 330, which I've already selected. Okay. So again, you can control R, rotate, 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 however you want to do it. Just going to place that there, and then I need a second one up here. This one I think I am going to control R. Okay. So now we'll connect our power source here, and we connect this to our gate. We'll move this a little closer, connect, and then to our input on our gate. Okay, so now, say we want to see what these inputs represent, okay? So we want to know when this is a 0 and when this is a 1, even though it's fairly basic and we can figure it out. Sometimes you just want to be able to look at it. So what we can do is just place 2 more probes. Very, very simple. So place component. They're under indicators again. Probe, digital probe. We'll go with a different color just so it's separate from our final. So we'll go with blue. We'll place 1 probe on this input, and we'll place another probe. We'll control R here, and we'll place it on this input. So I'm just going to go ahead and move these labels out of the way. So we know that's a 330 ohm resistor. And then X2 is our probe here, and X3 is our probe here. And we see that they're both threshold of 2.5, so we'll go ahead and change them to 4.5. Okay. 4.5. Okay, so now we'll know when we're inputting a 0 or if we're inputting a 1, and we can then see what our expected outcome is. So now remember, this is a NAND gate, so it ANDs them together first and then inverts them. So if we have a 0 and a 1, that gives us a 0, which then inverts into a 1, so we would expect this to light up. If we have a 0 and a 0, we have a 0, which inverts to a 1, we expect this to light up. So the only time we expect this to be turned off is when we have a 1 and a 1, which would AND to a 1 and then invert to a 0. So if these are both lit up, this should not be lit up. If either of these are off or both of these are off, then we expect this to be lit up. So how is that going to happen, you might wonder? So basically, right now, we have our 5 volts connected directly in. With this switch open and this switch open, we have 5 volts here and 5 volts here. So that would be a 1 and a 1, so that would end in a 0. Once we close either or both of these switches, these will either be a 1 and a 0, or a 0 and a 0, or a 0 and a 1, and that will cause this to light up. So the way that we do this, once we have everything placed, right now nothing is happening. Once you build a circuit, nothing happens until you actually press run. So you can either press run or F5. So we'll hit run. So these are both 1s. As you can see, these are both lit up. We have nothing here. We close this switch. That becomes a 0. 0 and 1 is 0, inverts to a 1. So now we have a 1 here. We open this, we go back to our initial state, we close this, same thing, just like we expected. And then lastly, once we close this, we have 2 zeros, which still leads to a 1. So as you can see, it's very easy to populate a truth table this way. You have your 1 or your 0 on your inputs, and then you have your output right here. So think of this as your A and your B. And that is the easiest way to build a logic gate circuit. Okay, so that's the end of this video.